Hi, welcome to a brand new video. In this video, we're going to be solving the search insert position problem. In this problem, we're given a sorted array of distinct integers and a target value, and we need to return the index of which the target was found. That's pretty simple. But if we don't find it, we need to return the index of which it would have been if it was on the array. That is a bit more difficult, but still able to be solvable. First, let's tackle the first portion of this problem. Given a sorted array, let's return the index. That is obviously binary search. So let's code some binary search. Now, if you could do the arrays.binary search method, and then do num's target, and then say if num is greater than equal to 0, return num. We could do that as our binary search, but let's try actually doing the binary search itself. So in order to do binary search, we need two pointers. So we need the low pointer and we need the high pointer. I'm going to just set the high pointer num.length -1. And we say while low is less than high, we create a middle value. So that would be high minus low divided by 2 plus low. And we say if nums of mid. And if you don't really get what I'm doing, you can watch one of my previous videos on binary search, which is why I'm kind of going through this a little bit more quickly than I normally would. If it's less than target, we're going to set low equal to mid plus 1. Else if nums.mid is equal to target, then we're going to return mid, and else we're going to set high equal to mid minus 1. So if it goes through this and it doesn't return anything, which means we have lines of code here, that means that it wasn't in the array, because otherwise it would go into this because we would have had a mid value that was equal to target and it would have returned it. But since we exited the while loop and we don't have that value, that means we're going on to the second statement. If not, return the index, which it would have been if it wasn't inserted in order. Which means that what we technically need to do is we need to iterate through nums.length I++, and we're going to say that if nums of I is greater than target, then we just return I, because it's going to be less than up until this point. For example, in 2, this is less than, this is greater than, so it must be between the less than and greater than. Otherwise, if it's always less than, I don't have an example here, but for example, if we wanted to place 7 in this array, it's always going to be less than. That means you need to put it at the end of the array. So that'd be nums.length -1. So kind of as a recap, we did binary search to find the index where the target's found. If that does not work, then we're going to iterate through the array and see when it gets greater. And then that means we'll just place in between the lesser number and the greater number. And then otherwise, if it's always less than, then we just return the end of the array. And actually, we don't even need this -1. We can just do nums.length because we don't want to put in this position, we want to put in the position after. So if we run the code, then we see that it works with its test case, and then we can run it in submissions, and we see something happened here. And it's because you're inserting 1 again, and in this code, we always get the second value of 1. We want the first value of 1, so just do nums greater than or equal to target. And then perfect, it works. So I hope this video was helpful and see you in the next video.